Y'all missed my bad jokes, so we can just get right to it. I'm up here because I built a game engine. And hearing that, and by built, I mean I'm building, it's not done. Hearing that, you're all probably wondering much the same thing. Who in their right mind would build a game engine? Hi. I built it because I think my entire career is owed to projects just like this one. I'm going to talk about more of that at the end, but why specifically a game engine? Well, my day job is as a design engineer. And design engineer is just some new title for somebody who wears a bunch of different hats to bring software ideas to reality. And I had been looking for a project that was the intersection of these skill sets, and also one that I knew would be challenging, something that I knew would push me past like the limits of what I thought I could do, because as the great Kelly Clarkson said, what doesn't kill you makes you stronger. And as for this game engine project, I'm still not sure which one of those it's going to be. All right, skills. Boy, does a game engine involve a lot of skills. From engineering skills like pathfinding algorithms and isometric projection to design skills like attack animations, cutscenes, character sprites, not to mention storytelling that brings design and engineering together into something players hopefully can actually enjoy. So I think we can say that a game engine checks the box on both challenging and ambitious. So with that in mind, I probably picked a language that I was very familiar with, something that I use every day. Also, no. I picked Gleam, and part of it's just because I love functional programming, and Gleam reminds me a lot of my very first functional programming language, Elm. But Gleam is also, I think, the perfect fit for the type of game engine that I'm building, because I'm building a browser game engine. I build products for the browser. I'm going to build a game engine for the browser. That means I need access to browser APIs such as Canvas. I also need access to events like keydowns and clicks. Thankfully, Gleam compiles to JavaScript. But Will, JavaScript, you're very familiar with TypeScript. You use TypeScript every day at your job. Why would you not pick the language that you're familiar with? Well, thank you all for asking. Let me tell you. So reason number one, this is the output of one of the most basic type errors you can have, an incorrect key in a record type. Gleam is very friendly, if you can read that, and suggests, they recognize that it was very similar to an existing key, and they suggest what key you might have wanted. And in case that is not what you wanted, they also list out the other keys that are on that record type. TypeScript just yells at you that you're wrong, and you've got to go figure out what the key is yourself. Reason number two, who doesn't love pipelines? I could have also put pattern matching. You all get what I'm saying. We all love functional programming. Why would you not want to pick a functional programming language? And reason number three, one that's a little more concrete and less opinionated, is that I could write the same language on the client and on the server. And for those of you who know, you're probably like, dude, TypeScript is the same on the client and the server too. And you're not wrong about that. But the problem is that then you're stuck with a JavaScript runtime on your server. And let's walk through a little example on why I don't want that. All right, here we have our happy player and our server. In this case, it's demonstrated. We're going to talk about it as a JavaScript server. And our game goes viral for whatever reason. Games go viral. And all of a sudden, our little server is not happy anymore. We've got a bunch of unhappy players, too many resources being drawn. So that means we need to scale up. If we're using a JavaScript-based runtime, this is usually what scaling looks like. And I don't like servers or managing them, so this is not very attractive to me. But Gleam compiles to JavaScript, but it also compiles to another language in runtime. Gleam compiles to Erlang, and Erlang runs on the Beam. And for anyone who might not know, the Beam is very well known for being very good at handling a bunch of concurrent requests. So my one server can do a lot more with the resources that it has, and I don't have to worry about a bunch more servers until a lot later in the process. All right, enough about why I picked Gleam. Let's get into some of the lessons and the point of this talk. Now, there are 500 tiny lessons and interesting technical details while building a game engine. But I only had 25 minutes, so we are not going to talk about all of them. If you want to talk about them, come find me after. I would love to talk about anything that you have a question about. But for this talk, I have picked 2 contrasting lessons that I think generally apply to any ambitious project that you might want to take on. Lesson 1, at the start of any project is when you are the most excited. You have all the motivation in the world, and you hit that code base, and you are ripping. You are so excited, you are solving all the problems, but eventually reality sets in, and you run into some kind of roadblock. Something that seemed simple on the outside, once you get under the covers inside, had a lot of hidden complexity. And the lesson here is that's why they're called ambitious projects. Expect it. You're not going to get the reward of tackling ambitious projects if you're not willing to tackle the complexity that comes from solving those types of problems. But the contrasting lesson and the good news is that you don't have to do that by yourself. There are so many tools and resources, and especially with Gleam, there's an incredible community of people who are happy to help. Now, they're either going to help you because they are also excited about the project that you're working on, or they see how excited you are about your project and they just want to help. Either way, one of the best parts about taking on these ambitious projects are the relationships that you build because you go out and ask for help, or you go and show others the project that you're working on. So the lesson is you don't have to tackle complexity on your own. And that is my talk for today. I hope you have a good one. Okay, I'm just kidding. Let's dig into both of these lessons in the context of this game engine. And we're going to start out with the game loop for lesson number 1, a very humble and simple problem in theory, and the very first thing you have to solve to build any game engine. So right out of the gate, what is a game loop? Well, you have some state that represents your game, and you render it to some client. Then you go and update that state. Then you render it. Then you update it. I mean, we all understand loops. It's a loop. Let's dig one layer deeper and talk about how that works using the example of this cursor animation. So we have some state. This is a Gleam type. We have our total number of frames, and we have the current frame that our animation is on. We have an update function that just increments our current frame until you hit the max number of frames, and then it loops back around to the first frame. Now, I want to help y'all visualize what this actually looks like when you go to render it. So here we have us rendering our first frame. Then you go and update it to the second frame, but nothing happens to our visual until you render it again. And now we are rendering our second frame. And then we update to our third and render that. And you can see how this cursor moves throughout this animation. This is called sprite animation. And it uses, as you can kind of picture this, one image that holds every single frame of your animation. And so your render loop updates the state and then renders that until you get to the final frame, and then we go back to the beginning. All right. Pretty simple, right? Doesn't seem that bad. Well, let's dig another layer deeper and talk about how we are implementing that in the browser. We are going to use request animation frame. If you're not familiar with request animation frame, it is one of many looping mechanisms we could use, but it is also the best looping mechanism you can use for the browser for a few reasons. It is specifically built to sync with browser rendering. Other loops, they loop at whenever they want to. That may be in sync with the browser's render loop. It may not be, and it might interrupt it. Request animation frame is guaranteed to be synced with it. It's reliable over long run times. Other looping mechanisms, the longer they run, have the potential to drift. And drift in a video game means dropped frames, which means lag. We don't like that. All right. And resource efficiency. It's a browser. Somebody might get bored or want to go look something up, or might get sent a link from their buddy and they go check it on another tab. We do not want our game to suck the resources out of our player's computer by continuing to run. But we don't have to handle that because request animation frame automatically pauses execution when it is no longer the focus tab. All right, well, where's the complexity? That sounds pretty awesome. Well, let me talk about request animation frame's big problem. If you've played video games, you all know what this is. If not, this is frames per second. And it is how fast your update loop is running. And let's take a look at an example if we use request animation frame's default frame rate. All right, that's what we expect our loop to look like. This is what happens in reality. Why? Because for the majority of screen history, screens have refreshed at 60 frames per second. And request animation frames loop, why it's so consistent, is because it is based off the current screen's refresh rate. But these days, majority of computer screens and a lot of screens refresh at 120 frames per second. Yay, technology. Unfortunately, most physics engines and animations are all based off of this 60 frames per second model. Our first bit of complexity. How do we solve this? All right, do we all remember this graphic? This is what our game loop looks like. But our game loop also sometimes looks like this, because we always want our render to be running as fast as the screen will allow it. But we don't always want to update. It is not good if your update sometimes runs at 120 frames per second and sometimes it runs at 60 frames per second. You have got to constrain your update, which means sometimes you've got to skip it because it hasn't been 60 frames per second. This is called fixed update variable render. And let's walk through how we're going to solve that in Gleam. All right, we take our cursor state and we're going to throw it now in a game state type because we've got to put some more stuff in there. We need to add time. If you're going to try to measure when you should update based on the last time it updated, you've got to have that available. So we have time. We also are going to add a constant that represents 60 frames per second in milliseconds. Request animation frame has all of its time in milliseconds, so we need to have access to a constant that represents 60 frames per second. We have our update function. It takes game state and the current time, which is what we're getting from request animation frame. And we calculate if we have pending frames by getting the difference between the last update time and the current time of the loop and seeing if that value is greater than or equal to our fixed 60 frame per second constant. If we have pending frames, then we update our game state, update our cursor, and return that. But if it hasn't been 60 frames per second yet, we just skip it and go on with our lives. All right, pretty great, right? We've got our update loop. And now we skip it if it hasn't been 60 frames per second. But sometimes our update loop also looks like this. Why? Well, let's look at an example of comparing our game's last updated time to whatever the current time that we get from request animation frame. Let's say it's a difference of 38 milliseconds. All right, we've got our delta, we've got our function that says, okay, we've got enough time to run a frame, let's run our update. But does anybody notice what else could happen? We've got enough time that we could fit a whole nother frame in there, but we're not accounting for that. So that frame gets dropped, and suddenly our game has dropped frames. Nobody likes that. So we've got to update our function to be recursive, to call update as many times as we have in that delta to run a frame update. So we split our initial constant up, our initial variable up, and just capture the time since the last update. And then we pass that, along with the game state and the current time, into our update loop function. All right, so we've got our game state, current time, our delta. Now we check to see if there are pending frames with the delta that was passed in. So if there is 60 frames per second's worth in our delta, we kind of do the exact same thing as before. We update our game state with the current time of the update. We update our cursor. But then we recursively call this function again, but we have taken one frame out of our delta. So now the next time that we run our loop, that value is a little smaller. And as long as we have 60 frames worth of updates to make, we keep updating it until we don't, as seen by this pattern match. And if it's false, we just return our game state. All right, all of our problems solved, right? We have now accounted for our other frames, okay? But there's a problem. Does anybody notice this guy? Did anybody notice it in the last graphic? Yep, this one right here. Mr. 4.46 milliseconds. That's not that bad, right? Who cares about 4.46 milliseconds? Until you realize that after 4 frames, 4.46 milliseconds is an entire frame. And then you're thinking, okay, that's still not that bad, until you realize that that's 15 frames that get dropped every single second that your game is running. Not great. All right, more drop frames. We don't want those. Enter the accumulator. That little guy, we have to track him, and we accumulate him over every loop until he equals a full frame, and we have to account for him. So now we update our function once again to add on the accumulator at the beginning of our calculation. That gets passed in. Our update loop stays basically the same until we no longer have the space to do another update loop. And then we just save that delta to our accumulator, and it gets factored into the next time, solving all of our problems. Still no. It's the browser, like you might have a slow connection. There might be some kind of issue with their internet. Who knows what happens in the browser? You've got to account for everything. And let's say our last updated time and the current time has a difference of 170 milliseconds. Once again, these don't seem like big numbers until you think about them in terms of updates. 170 milliseconds is 10 updates, 10 loops. And by the time you're doing 10 loops, send it back to render to the client and come back, guess what? Now you've got 20 frames to update. And then you've got 40 frames to update. And we all know where this is going. A death spiral. And suddenly your game freezes because you have too many updates. Well, this is thankfully, I think, the easiest to solve of all. We just have to track like a kill condition for our function. A loop count, a maximum number of loops that we're going to allow, because sometimes things will happen really quick. Sometimes we might needed to skip the update, but guess what? Because we capped out our loops, we have some space we can catch up the next time we come back around. So it's not too big of a problem. In the function, we not only check if there are pending frames, we also just make sure that our loop count is less than our maximum. And then when we recursively call our update loop, we increment that loop count. I think you can all understand how that works. And then we initialize it with 0. All right. The simple game loop, right? Always hidden complexity. It is always fun to figure these out. And lesson number 2, we don't have to figure these things out anymore. I mentioned community. The Gleam community is great. I'm not going to talk to you about how to talk to other people. I think we can figure that out. I want to talk about AI. Now, whatever your opinions are about it, there's a lot of love, there's a lot of hate. I just want to explain in the context of this how it is useful for people who are taking on ambitious projects. One of the biggest and hardest problems when starting any new project is understanding a domain that you've never worked with before. We are all really good at searching for problems. That's just like one of the skills of a programmer. But it is very hard to search for things you don't have the language for, that you don't have the domain for. AI solves this cold start problem. You don't have to do all the time and effort and research to figure out what the language is. You can ask questions in the language you do understand, and AI can synthesize a whole lot of data and explain it to you and allow you to progressively and much quicker get into a new domain. And then you learn the language, and it falls right back into the patterns that you have from before. Very useful. Rapid iteration. If you want to know what feels like magic, it's trying to define a magic system with the help of AI. It is so much faster to be able to ask questions like, what are the benefits of X versus Y? Like, should I allow every class member to have a customizable class? Should I have fixed progressions? Should I allow only some attributes or, more complex combinations? These type of, what enemies might exist on different floors, different environments. The age-old problem, what do I name this? And I'm not talking about like variables, I'm talking about like creatures and things in a game. Like the naming just is everywhere. AI helps with all of this. And AI and LLMs are not perfect. It's your job to refine the things that you get. Sometimes you get a whole lot of junk. Sometimes you get something that's really useful. I've got plenty of stories of like really useful things that happened while I was doing this, but I don't have time to talk about all of those. So let's talk after. But I want to wrap up my talk with something just a little more general and less focused on game engines, which is an argument for why you should take on ambitious projects. This is my career. I was not even a developer or in web design. I went to school for industrial design. My very first ambitious project was teaching myself how to code. And the second lesson of getting help from others, the first job that I got was because that I got help from another company and built a relationship with them. They were my first job in development. And I wouldn't have had that if I had not taken on this ambitious project and made that relationship. So I got the future that I wanted because I was willing to get out of my comfort zone. And if there's one thing that I want you to get out of this talk is not, wow, isn't he so awesome? Like, wow, he did that. No, I want you to be like, wow, he did that. Like, if Will can figure this out, then like I can definitely go out and figure out some ambitious projects. Because I want to share with you my favorite secret about ambitious projects. You don't need to succeed to be successful. 6 years ago, I made, past tense, an Elm podcast, just one season. So I'm not some famous podcaster, but because of that one season, I got one of my jobs that I previously had because I did that. Not to mention relationships and friendships that I still have. And so the question is, I think, should I do an ambitious project? The answer is yes. I think you owe it to yourself that if you are not already on the path to the future that you do want, to tackle the big gap of hard work and unknowns to get there. My name's Will King. I'm a design engineer at Crunchy Data. We have the world's best Postgres experts backing the most reliable managed service in the market. You can find me at wking.dev or on X at wking__. And of all the ambitious projects that I've talked about today, this is my most ambitious one by far, and also my most rewarding. It's my lovely wife and my 3 kids. My lovely wife, who I left on Mother's Day to be here with you all, so pray for me. Thank you.